So I'm here today to talk to you about JSON and PLV8 inside of Postgres. And I also want to mention I like birds. And so I've been touring around Amelia Island with my husband. And so I included a lot of pictures of the birds that we've seen in the past few days that we've been here. So pardon my birding. But I ended up titling this schema liberation. And the reason why I use that phrase is there's a lot of tension between managing your data with schema design and what DBAs typically do, and the flexibility of JSON objects and documents. And there's a misconception, I think, that once you enter the world of database schemas, that it's just all twisty mazes of SQL and slow tests and really sad developers doing database migrations. But Postgres actually has for a long time supported key value stores inside the database. This thing's called HStore. It's something that some of you here may have seen or used before. But even with HStore, there's kind of a mismatch between what developers actually want to use and how the database demanded that you store and manipulate that. So there really is this gap between what DBAs think that you should do and what developers really actually want to do. And I want to talk about this idea of schema liberation and I base this on conversations I've had with people about MongoDB. And no one ever said those words to me exactly, but what they really did talk a lot about was freedom. This is from the MongoDB documentation. It's just a short excerpt that I think sums up a lot of what developers really love about document store databases. I think it's this flexibility. It's making database objects that very closely resemble what it is that you're doing in the application. And I hear this from developers a lot, that they wish changing their schemas wasn't so hard, that they had better working relationships with their DBAs, and that deploying these features into the data store was just way easier than it is. So I just want to show you an example of what this, what this typically looks like and what it really would be better as. So let's say you were recording your bird sightings. Just a bunch of SQL here. This is what it might look like if you were trying to store these sightings in a SQL database. You'd create a bunch of tables, a bird table, a locations table, a sightings table, put this data into the database, a bunch of inserts, and then you'd have a join table to put that in there. Or, we could just store the JSON. And looking at this, it's really obvious to me which one is more friendly to the developer. And I think for a long time, DBAs have been pushing this problem of early optimization onto developers, and I'm hoping that having JSON in Postgres is going to make this a lot easier, and we can just help developers enjoy working with relational databases a lot better. So could Postgres be as flexible as MongoDB? Could we make developers as happy using a relational database as they are using document store databases? Well, the ingredients to do this right now, 9.3 Postgres, which is out in beta currently. You can download this and try it out today. Or Heroku has actually loaded all of these tools that I'm going to show you today in their development databases, so you could fire up a Heroku database and test it out. And they have PLV8 ready to use there. You can also use it with 9.2 Postgres, but you have to load an extension called JSON enhancements in order to get all this functionality. So V8, I have this slide in here. It's mostly for the benefit of the people who aren't here today, but after Brendan's talk, of course, you all know what V8 is. And PLV8 is embedding V8 inside of Postgres. And you can see a lot more about PLV8 in that link there. So I'm sure many of you deal with normalized tables in the database. So let's say we have a table called reports. Let's look at what this might be like. And this is an actual table that I have to deal with. There's like 38 columns here. You see all these different data types and things like that. And it's just not very fun to deal with. So let's just convert this to JSON. So if you were to take an existing schema today and you wanted to pull all the data out of it, very simple thing you can do is just to select star from reports, right? And that would give you all the data. But I want to convert it to JSON. So there's actually a function in Postgres that enables you to do this. It's called row to JSON. But this query won't actually work. You would have to use a subselect in order to pass it to it. So because row to JSON expects a record type. So with this right here, I would pull all of the data out of that reports table, convert it to JSON, and spit it out. But what I really want is a table. I just want to shove this all into a table. And Postgres supports this really great syntax for taking the output from a query and dumping it directly into a table. You don't have to specify any of the column types because Postgres already knows what it is. So you can just put your SQL query right in there, generate a table. So magically, there we go. This is what it looks like in Postgres. You end up with this table. I called it liberated, so I was feeling liberated. And then my column name is row to JSON. You could change that if you wanted, but that's how it turned out. And so I did this on a development database that I have that has a copy of our production data. It took about 2 minutes. It was an older dev system. This entire table fit in memory. It was about a 2 gig table, and there were 2.7 million rows in it. So it was pretty fast. It didn't take me very long. And there's a penalty for denormalization, right, in terms of the amount of disk that we're going to consume. So you can see here the first table, my original table, was 2 gigs, but the JSON table was about 4. So, right, we pay a little bit of a price there, but honestly, I don't really care. I got disk to burn. Let's just liberate our entire database, right? So I wrote a function using PLV8 to liberate your entire database. And some friends of mine have tried this out, so it actually does work. It's terrible JavaScript. I apologize. I'm not a JavaScript developer. I think my JavaScript looks like SQL. Well, there's a lot of SQL in there. But anyway, so you could use this today to convert some existing database that you had in Postgres. And I was just going to go through this really quickly to show you kind of how simple this really is. So a lot of this ended up being about 25 lines with all my pluses and whatever's in there, but it's really only about 4 lines of JavaScript. But there's quite a bit of boilerplate. So the first thing here is this create schema liberated. And all this is a namespace. The terminology in Postgres is a little different than like MySQL. We call a cluster a group of databases, and that's like an instance of Postgres. A database contains schemas, and then these schemas are these namespaces that contain tables. Because I wanted to shove those all in there and be able to drop them when I was done easily. So then the boilerplate around here is, again, it's pretty simple. It's create or replace function. I gave it a function name, and I'm not passing in any arguments because I'm just going to convert everything. It's going to return a Boolean. And then the language is PLV8, obviously. And then we've got an as function that signals, OK, now we're going to shove some JavaScript in there, and then the end. And I had 2 SQL queries in here that were a little bit, complex. Not too bad. And this right here shows you pulling out all of the table names from Postgres. So when you're looking at objects inside there, Postgres comes with an internal schema called PG catalog, and you can query all of that data in there just as though you were looking at an ordinary table. So that's kind of convenient. So now I've got a list of all of my tables that I want to convert. And then I'm just going to reuse this query that I wrote earlier to create all the tables that I want without having to specify anything about the actual structure of those, other than the fact that there's a report query. So there you go. So that's it. Pretty simple. var tables, got a for loop. I'm doing a little e-logging to let me know that as each table is being processed, and then I execute it. My friend Craig tried it out, so yes, it does work. He was already using the JSON data type, so it was like JSON within JSON, which wasn't very good test. But anyway, he tried it out, and it definitely did work on our first try. So if you're thinking about using this, I want to let you know that the JSON data type is a first-class data type. You can index it, you can join against it, you can compare it. There are operators that are defined for it. You can write functions for it, as I just showed, and you can return it the same way you would return an integer or a text type or any other typical database type. So you might have already inferred that this would be the syntax for this, but you can just create table, give a name to the column, and then you call the column JSON, and that'll create a table for you. And then inserting data in there is very simple. Just insert into table name, values, and then a JSON object straight into there. And then down below I show a select. When you select from it, it just outputs straight up JSON. There's quite a bit of predefined functions that we've put in there for helping you look at this stuff. So they're not always the best names. Naming is hard for us, but they're very well documented. So I've got 3 here that are pretty commonly used. JSON object field text, return a field of text. JSON object field, which will return a quoted value in the event that you're looking at things that aren't text. And then JSON object keys will return all the keys in there. And like I said, you can use these because Postgres supports functions as indexes. You can create any kind of index you want against this, compare it, join it, and use it just like any other column. V8's also trusted, so you don't have to be a super user to create and run functions using PLV8 inside the database. This is not true of something like Python, for example. Python's an untrusted language, and the same goes for a lot of the other languages that we support. We actually support Lua as well. Lua is trusted. Anyway, so you can create and run these just as a normal user. PLV8 automatically parses JSON input. So if you're doing something like this, where you input JSON column and you have a key text, you can see right there that I just immediately was able to use that object without running JSON parse on it. PLV8, of course, also supports running raw SQL and prepared statements. You can, so yeah, here's just some examples: execute, prepare, execute. We also support cursors, which is an advantage if you've got a lot of data and you just want to transfer one row at a time in your return function. And I just threw this up here because it makes me laugh. We can not only have SQL injection, but we can also have JavaScript injection directly in the database now because of our support for PLV8. I don't know that you'd want to actually run this in production. I do know some people that have written things like this and then stored their JavaScript directly in the database to avoid having to load lots of functions time after time. But yeah, I don't know if this is really advisable. It's kind of hilarious, though. So all that stuff, that's cute. I'm telling you the theory of how you might use this. But what about in production? What does this actually look like? So I too work at Mozilla, although not on anything really JavaScript related. I help run this thing called crashstats.mozilla.com, and this is every time Firefox crashes, which I'm sure is very rare. We look at those, and so we have this tool. It's basically a data warehouse tool analyzing this. And here's a picture. This was made by a contributor that shows you what our internal structure is like. All the systems that are running to make this thing go. And you can see there's 2 main data stores here. We've got HBase up there in the corner, and then Postgres, very looming large in the middle. You can kind of see the contributor's preference for Postgres here. It's a little misleading, though, because our HBase cluster is actually about 150 terabytes, and the Postgres cluster is only about 2. There's a lot more interaction, a lot more tools that are interacting with Postgres than HBase, but anyway, thought I'd point that out. So we've got all of this data in HBase. It's about 70 to 75 machines there, and then there's only 3 or 4 systems running the Postgres database. So if we go back to this reports table, which is sometimes the bane of my existence, it's very large, it's complex, it's not very well documented exactly, and it becomes a real pain to, it's not too difficult for me to add columns to this when we add new information to our crashes, but it's not the greatest either. So we started talking about this when 9.2 came out, and we ended up upgrading our systems last fall to 9.2, and then we just created this table. It has the crash UUID, which is how we uniquely identify all our crashes. It has the date processed, and then it just has this JSON blob of everything in it. And we put this into production at the beginning of May. And here's a look at what this looks like. It's very similar to the dev system that I just showed you, actually. So our production reports table is about 2 gigs in size, and the production raw crashes table containing all the JSON is about 5 gigs. So, I actually had forecasted this out that it potentially could be quite a bit larger. We don't know what size the crash object is going to be ahead of time. There's no way to tell. But I had suspected it would be somewhere, somewhere around here. And so anyway, so we had to upgrade all our disks to support this, but now we're pushing somewhere around 5 gigs of raw JSON into the database, and we're going to probably double that very shortly because we actually have, in addition to the raw crashes, we have a processed crash that has a little more metadata in it that we're going to shove in there. So and if you look at this, the comparison here is JSON at 2K per crash, and then a normalized table would be somewhere around 0.8K. So there's a couple lessons from that. Like one, of course, right, we're going to burn some disk when we do this. It's also that good DBAs do actually save you some disk. There's a reason why we normalize data. But when you're in a situation like we are, where we don't really know what kinds of reports we want to run ahead of time, it's very useful to have immediate access to that data. Which brings me to what really is the killer advantage of doing something like this in Postgres as opposed to, say, HBase. And it really is this. So I needed to look at a single value. We were interested in the garbage collection, and is garbage collection running when Firefox crashes? And so I first wrote a MapReduce. We use pig, and then there's another tool called JDoop, which is actually you can write some Python and then run a MapReduce against HBase. So I wrote my initial query, and I was looking at about a week to 2 weeks worth of data, and it literally took 30 minutes for me to get all of that data, transfer it to the host system, and then process it into a report that would be useful to somebody. On Postgres, it took 24 seconds. So that saves me, my time as a developer is finite, and if that's going to save me 25 minutes for every time I need to run an ad hoc report, it's totally worth it to chew up all the disk. So that's really been my motivation to moving this into Postgres. We're still going to use HBase for storing we've got these dumps, these binary dumps of data that are a little bit large. They can be quite large. So we're not going to store those in Postgres, but all the metadata, all of the JSON that we're storing, we're just going to pull it all in the coming weeks. So why would you use Postgres? Just to sum up this stuff, why would you use Postgres to store your JSON as opposed to a NoSQL system? Well, I think the most compelling thing, especially for those of you who are running reporting systems and doing visualizations of data, and I think there's quite a bit of that going on right now. I like to I started calling this bulk bag schema design. It's something I got from Will Leanweber, who got it from some comedy podcast. But I think it really describes what you're trying to do. You just want to throw everything into an unstructured data store initially, and then have the option to optimize it over time. Initially, especially in the prototyping stage, you don't really know what your reports are going to look like. You don't really know how you want the data to be stored. And that premature optimization, I think, is a silly and unnecessary hurdle to development at this point in time. If you're using Postgres, it's going to be easy for you to scale to multi-terabyte database instances. And particularly for these write and read heavy loads having to do with reporting, like our workload is mostly write. And Postgres does a really great job of handling that. My one caveat on this is that if you're scaling to multi-terabytes, non-cloud storage is probably a better option, particularly for the reporting workloads. There are some great examples of people using the cloud with Postgres, and I think Instagram is probably the best example of that, and they've published a few different talks about how they're managing that. But it is pretty easy to scale these individual Postgres instances to multiple terabytes. And finally, I think Postgres is a really great option because you can manage your data with a language that you already know and love, which has not really always been an option, right? Previously, people would, you'd either have to write raw SQL or you would have to use a language like PGSQL. And I think that being able to write JavaScript inside the database makes it far more maintainable. I think it makes it a lot more likely that the developers that I'm working with will actually write data processing code as opposed to leaving that to the database experts. And then also being able to put that code right next to the data inside the database makes it a lot more efficient because you're not having to transfer it over the network to process it. So, like I said, 9.3 beta, it's out today. You can download it and play with it. All these tools that I was talking about, they're also available. If you want to create a developer instance in Heroku, you can play around with it, and it works really awesome. And if you want to know a little more about the types of features, I just listed a bunch of things here. I'm not going to go into all the cool things about Postgres, but I just ripped most of this from a slide from Craig. There are so many things about Postgres. I've been talking with quite a few people here at the conference about the JSON data type, and I've had more than one person say, "Why didn't you tell me about this last year?" I've had to build things in the last year that really would have this really would have helped me out. And I think that Postgres actually has a lot of those types of features where you're like, "Oh wow, that would be really great." But anyway, I made a list here. Definitely check it out, and feel free to ask me questions. And so, liberate your data. Let me help you liberate your schema today. Thanks.